Alrighty, so let's dive into triangles. In this unit, we're going to be talking about triangles. Okay, first off, we got to do some vocab. What are triangles if we want to classify them by their sides? Well, if there are no congruent sides, this is called a scalene triangle. Okay, if there are at least two congruent sides dictated by these tick marks, this is called an isosceles triangle. And if there are all three sides are congruent, that's called an equilateral triangle. Okay, all the sides are congruent. What about the angles? Okay, if your triangle has three acute angles, it's known as an acute triangle. If it has one right angle, which is the most a triangle could have, it's known as a right triangle. If it has one obtuse angle, which is right here, that's the most a triangle could have. That's known as an obtuse triangle. And then if all angles are congruent, that would be an equiangular triangle. Okay, so when we're classifying a triangle, we want to classify it by its sides and by its angles, if we can. Okay? And there's a relationship between the angles and the sides of a triangle. We'll get into this a little bit more in the next video. Okay? But if angles are congruent, the sides opposite those angles are congruent. And vice versa. If sides are congruent, the angles opposite those sides are congruent. All right? So since angle A and angle C are congruent over in this diagram, if I traverse across my diagram, these sides that are opposite of the angles have to be congruent as well. All right? So there's definitely an angle-side relationship going on when we're dealing with triangles. So in example 1, let's classify the triangle by its sides. Then determine if the triangle is a right triangle. So what we need to do is we need to plot these points. -1, 2, that's A. 0, 0, that's B, and C is at 6, 1, 2, 3, which is C. Okay, so I'm going to connect these. So we need to classify this by its sides, which means I need to know what are my side lengths. So I'm going to do that by using the distance formula or Pythagorean theorem to figure out what are the lengths of my sides. Okay, so for AB, if I wanted to draw a right triangle to find the length of AB, my vertical change is 2, my horizontal change is 1. Okay, so AB squared is equal to 2 squared plus 1 squared. So that's 4 plus 1, which is 5. So AB is going to be the square root of 5. AB is the square root of 5. Okay? For what's next? BC. If I set up a right triangle to solve for BC, my horizontal change is 1, 2, 3, 4, 5, 6. My vertical change is 3. So 3 squared plus 6 squared is equal to BC squared. 3 squared is 9, 6 squared is 36, equals B squared. So BC is going to be the square root of 45. All right, which equals, if I break this down to the square root of 9 times the square root of 5, 3 square roots of 5. All right, so BC is the square root of 45, which equals 3 square roots of 5. And then last but not least, AC. So if I set up my right triangle, the vertical change is 1. Sorry, the vertical change is 1. The horizontal change is 1, 2, 3, 4, 5, 6, 7. Okay, so if I'm doing Pythagorean theorem here, 1 squared plus 7 squared is equal to AC squared. So that's going to be 1 plus 49, or 50, equals AC squared. So AC is the square root of 50. which is going to equal 5 square roots of 2. Square root of 50, which is equal to 5 square roots of 2. Okay, so first off, classify this by its sides. So the sides we're looking at, do I have any congruent sides? No, I have square root of 5, square root of 45, and square root of 50. All of those side lengths are different. Okay, so since I have no congruent sides, this is a scalene triangle. Okay, next up, we need to determine with the angles. Now, in the coordinate plane, all I can do right now, is see if I have a right triangle. And remember, a right triangle happens if two lines are perpendicular. If you remember back from last unit, lines are perpendicular if they have opposite reciprocal slopes. So I need to find the slopes here. All right, let's see. The slope of AB, the rise over run, is down 2 to the right one. So down 2 to the right one. The slope of BC is up 3 to the right 6, which simplifies to 1/2. So right there, I can stop. Let me move this BC out of the way. Because these are opposite reciprocals, which means that if I zoom in here, when AB and BC meet at this vertex of B, that's going to be a right angle. All right, because those are opposite reciprocal slopes, so those two lines are perpendicular. So this is a scalene right triangle. All right, so that is how we classify triangles based off of side lengths in the coordinate planes and how we can determine whether a triangle is a right triangle there. In the next video, we'll start talking about angles of a triangle more.